Most drivers assume that if an oil says full synthetic, it must automatically protect their engine. But what if that assumption is wrong? What if two oils with the same label behave completely differently once heat, pressure, and time are involved? That's exactly what this test set out to uncover. 8 popular synthetic motor oils were put through identical conditions, identical engines, and identical stress cycles to find out which ones actually protect internal components and which ones quietly fall apart. The results were far more dramatic than expected. After extended high-temperature operation, some oils remained clean and stable, while others darkened rapidly, lost viscosity, and left behind deposits in critical areas. What made this especially surprising was that price and brand reputation didn't always predict performance. Some well-known names struggled, while others performed far beyond expectations. Before revealing the rankings, it's important to understand a major misconception about synthetic oil. Synthetic is not a single formula. Oils are built on different base oil groups, ranging from heavily refined mineral oils to true synthetic compounds engineered at the molecular level. Most store-bought synthetics rely on Group 3 base oils, which are refined from crude oil and chemically modified. They perform well initially, but tend to lose viscosity and resistance under sustained heat. Higher-end formulations use Group 4 or Group 5 base stocks, which resist oxidation, shear, and thermal breakdown far more effectively. That difference becomes critical over long intervals and high engine loads. To eliminate variables, 8 identical 4-cylinder engines were mounted on controlled dynamometers and run through extended driving simulations. Each engine experienced cold starts, idle time, city driving, highway cruising, and sustained high-load operation. Temperatures ranged from near freezing to extreme operating heat. After testing, oil samples and engine components were analyzed for viscosity retention, oxidation, deposit formation, additive depletion, and wear metals. The oil that finished last showed clear limitations under stress. While it performed adequately during light operation, its additive package struggled when exposed to heat and fuel dilution. Internal analysis revealed early signs of wear and reduced protection in bearing surfaces. This oil may be acceptable for short intervals, but it lacks the durability required for long-term engine protection. Next was an oil known for its aggressive marketing and advanced additives. It delivered solid wear protection during high-load operation, but extended heat exposure revealed weaknesses in oxidation resistance. Light sludge formation was observed in upper engine areas, suggesting long drain intervals may not be its strength. While capable under performance conditions, it showed limitations during prolonged use. The next oil surprised many by staying remarkably clean. Its base oil chemistry resisted oxidation extremely well, leaving piston areas largely free of deposits. However, wear protection, while acceptable, didn't match the top performers later in the test. This oil excelled at cleanliness, but fell slightly behind in long-term anti-wear performance. Moving higher in the rankings, the next oil delivered balanced, consistent results across nearly every category. Viscosity remained stable, foaming was minimal even at high RPM, and wear metals stayed low. This oil didn't dominate any single category, but it didn't show weaknesses either, a strong all-around performer suitable for a wide range of engines and driving conditions. The final oil in Part 1 marked a clear jump in performance. Viscosity retention remained extremely stable even after prolonged heat exposure. Oxidation resistance was excellent, and wear metal levels were among the lowest observed so far. This oil demonstrated why higher quality base stocks and robust additive packages matter when engines are pushed beyond ideal conditions. It set the benchmark that the remaining oils would have to beat. And in Part 2, we'll reveal the top 3 oils, including one that barely changed after the entire test, and explain why base oil chemistry matters more than price, branding, or marketing claims when it comes to protecting your engine for the long haul. By the time we reached the top 3 oils, the differences became impossible to ignore. While the lower-ranked oils showed visible degradation, thinning, and early deposits, these final contenders behaved very differently under the same stress. Heat, load, and time simply didn't affect them in the same way, and that difference shows up where it matters most, inside the engine. The oil ranked third delivered some of the most impressive durability results of the entire test. After extended high-temperature operation, it showed almost no change in viscosity, and wear metals were exceptionally low. Bearings, cam surfaces, and timing components remained clean and smooth.
This oil uses a true synthetic base stock engineered to resist shear and oxidation, which allows it to maintain a stable protective film even under extreme pressure. Its only downside is availability and cost, but in terms of raw protection, it clearly belongs among the best. The second-ranked oil took a different approach. Instead of relying only on base oil strength, it focused heavily on advanced additive chemistry. Under the microscope, engine parts coated with this oil showed extremely strong boundary lubrication, meaning the oil chemically bonded to metal surfaces to protect them during cold starts and high-load operation. Foaming was near non-existent at high RPM, and internal components stayed remarkably clean. This oil performed exceptionally well in turbocharged and performance-oriented engines, where heat and pressure are constant threats. Then there was the number 1 oil, and its performance stood apart from everything else tested. After the full test cycle, it barely darkened, retained its viscosity, resisted oxidation, and left internal engine components looking almost untouched. Wear metals were consistently low across all samples, and deposit formation was virtually non-existent. This oil achieved near-perfect balance between base oil quality and additive design, allowing it to excel in every category instead of just one. What made this result especially important is that it proved a key point. The best oil isn't defined by marketing claims or price alone. It's defined by how well the oil maintains stability under real-world conditions. Oils that resist breakdown, maintain film strength, and keep contaminants suspended protect engines far longer than oils that simply perform well on paper. After reviewing the data with lubrication specialists, one conclusion was clear. Base oil quality and additive balance matter far more than brand reputation. Oils built with advanced base stocks and well-designed additive packages consistently outperformed oils that relied primarily on refined mineral bases. This explains why some engines last hundreds of thousands of miles with minimal wear, while others fail early despite regular oil changes. Choosing the right oil depends on how your vehicle is used. Engines that see frequent short trips benefit from oils with strong detergent systems. Long highway commuters need oils that maintain viscosity over extended intervals. Turbocharged and performance engines demand exceptional heat resistance and film strength. Matching oil characteristics to driving conditions matters just as much as choosing the right viscosity. However, even the best oil cannot compensate for poor maintenance habits. Extended oil change intervals, low oil levels, incorrect viscosity, or cheap filters will shorten engine life regardless of brand. Data shows that most engine failures result from oil neglect, not oil choice. High-quality oil works only when it's used correctly. The final takeaway is simple. Engine longevity isn't about finding a miracle oil, it's about understanding oil behavior and making consistent, informed decisions. Use the correct viscosity, choose a well-formulated oil, pair it with a quality filter, monitor oil level, and change it before breakdown begins. When oil is treated as a strategy instead of an afterthought, engines don't just survive, they thrive. And the engines that last the longest aren't lucky, they're protected properly every mile.